Hi everyone, here are your section 4.2 notes. So what we're going to be getting into today is more specific things about triangles. In section 4.1, we talked about how to classify triangles. We talked about the sum of the interior angles inside of a triangle, and we talked about the exterior angles in the triangles. So now we're going to get into what the guts or the meat of chapter 4 is about, which is congruent triangles. But before we can get into congruent triangles, we need to discuss what congruent figures are. So your definition of congruent figures, please write down, are when two figures have the same angle measures and the same side lengths. So when you have congruent shapes, right? Shapes is just another word for figures. They're going to have the same angle measures, which makes them look like the same shape. They're going to have the same side lengths, which make them the same size. So similar, another way to think about congruent figures is same shape, same size. When you have congruent figures, you have what we call corresponding parts. And your corresponding parts are the matching parts of congruent figures. And there are going to be corresponding sides and angles. And the number of those corresponding parts will depend on the type of shape that it is. So if it's a triangle and a triangle congruent to each other, then you would have 3 congruent sides, 3 congruent corresponding angles. If it was a quadrilateral, then you'd have 4 congruent corresponding sides and 4 congruent corresponding angles. Okay, so you'll see what I mean on this next example. So, example 1 says, write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. So, the first thing we have to do is write a congruent statement. And what a congruent statement is when you say something is congruent to something. So, remember our congruent sign is the equal sign. That's a really bad looking squiggle. I can do better. Congruent, there we go. So what are we talking about being congruent? Well, we want to specifically write about our triangles being congruent. So this is how we name a triangle. So if you remember back in geometry, we talk about using symbols instead of writing words out. So if I wanted to name this triangle right here, I'm going to write a triangle for the word triangle. And then I'm going to put the 3 vertices in any order. So I could do triangle ABC, or I could do triangle BAC, or I could do triangle CAB. I could do any combination. I'm going to be original and go ABC. Okay, it doesn't matter. That first one doesn't matter, but the second one does. So triangle ABC is congruent to the second triangle. I'll show you why here in a second. So now I have to pick out the corresponding parts. So I'm going to write triangle. Now notice over here we listed A first. A is the right angle. Where's the right angle over here? F. So I'm going to put F first. Then we want B. B has a single congruent arc. G has the single congruent arc. So I'm going to put G in the middle. And then we did C last, which was double arcs. H is double arc. So it does matter that you have your angles matching up with each other. Okay? Those are your congruent parts. So congruent figures have all the angles exactly the same, all the angles congruent with each other, which in this case they do, and all the sides. Notice if I look at my sides, I got a single tick mark, double tick mark down there, double tick mark up here. I have a triple tick mark, right? So I've got all these congruent parts between the 2 triangles, which tells me that they're congruent. Okay, so here is the first part of the question. There is my congruent statement. Now I want to identify all pairs of congruent corresponding parts. So we're going to have congruent corresponding angles. So we're going to make a list of the angles, and then we're going to do a list of the sides. The angles are probably easier. So angle A, remember, was our right angle. Angle A was congruent to angle F in the other triangle. So now here's a new different type of congruent statement. This is a congruent statement of angles. So angle A matches with F. Notice that A is my first letter in my congruent statement up top, and F is the first letter. So if I use that idea, B should match up with G. So I'm going to write down here, angle G is congruent to angle B. I guess I should maybe have done, keep it the same. B is congruent to angle G. Not that it would really matter. And then the last letter we had is C, which would match up with H. So angle C is congruent to angle H. Now the sides get a little bit more challenging. Okay, so now let's do the single tick mark. Single tick mark on the left triangle is side AC, so that's a line segment, so I'm going to call it line segment AC. Matches up, where's my single tick mark on the other side? HF. But now I do need to think about the order. Is it going to be FH or HF? Well, I did A, which is right angle, to C, which is double arc. So over here, F is right angle to H, which is the double mark. So it's going to be line segment or side FH. Now let's do double tick mark. So double tick marks here at AB. So AB, line segment AB, is congruent to, double tick mark would be line segment FG. And then triple tick marks, it's on our hypotenuse here. So I'm going to go BC. So again, it doesn't really matter the order, but as long as you have your corresponding parts matching up. So B would match up with G on the other side, and then C matches up with H. So I have 3 sets of congruent corresponding angles, and I have 3 sets of congruent corresponding sides. Once you have this congruent statement, you don't really need to even look at the diagram, because as long as that congruent statement's right, you should be able to just come up with the corresponding parts by looking at it. So for example, if I just made up a new one here, this is not in your notes, so triangle DEF is congruent to triangle JMO. So if I want to do angle D would be congruent to angle J. They're both the first, right? Angle F would be congruent to angle O. I'm going to get this one challenging. Are you ready? Angle FED, because remember that's one way we can name angles is using 3 letters. That would match up with, if I go FED, then the other side should be OMJ, right? Or if I wanted to do some sides, side FD would be congruent to, FD would match up with OJ. Or side ED should match up with side MJ. See how it works? So I don't even need those diagrams. I just need a correct, true congruent statement, and I can pull out all the parts just by looking at it. Okay, so our last example here. Now we no longer have congruent triangles. In this case, we have congruent quadrilaterals. So when we do a congruent statement for anything larger than a triangle, we just list the vertices in order. We don't put a little symbol in front of it. So notice that the top quadrilateral has vertices of Q, R, S, T, and the bottom one has W, X, Y, Z. So we're going to use that congruent statement in order to solve for X and Y. So I want to solve for X first. Well, I see an X right here, a lowercase x. Don't confuse it with that X right there. But I also have a Y involved, so I'm going to ignore that for now. Notice I do have another X right there at 5x plus 5. And it has a little degree sign, which means that it is inside the angle. Which angle is it inside of? W, right? So now let's go up to the top here. W is the first letter listed on the right. The first letter listed on the left is Q. So since they are both in the same spot in our congruent statement, that means that they are congruent to each other. And what does that mean when you're congruent to each other? You have the same or equal measures. So I'm going to set those two things equal to each other. So 65 equals 5x plus 5. Subtracting 5 from 60 on both sides, or 65 gets us 60 equals 5x. So x is equal to 12. So there's our x. Now let's find our y. Well, where was my y? It was over here. And we just found x, so that really turns into the expression y minus 12. So now I'm going to ignore this. Okay, so now, because that's in inches and I don't have a little degree sign anymore, that means it's on an actual side length. What side length is it on? Well, it's on side length WX. Go back up to our congruence statement. WX, first two letters. First two letters on the left is QR. So now look at our diagram. What's the length of QR? 6. Well, if those are congruent quadrilaterals, that means that those sides should be equal in length. So I'm going to set 6 equal to y minus 12, which adding 12 to 6 gets me my y to be 18. Okay, so corresponding parts of congruent figures will be equal. All right, this concludes your notes.